Hi guys. Like you may know or not, last WWDC, Apple introduced an incredible technology about artificial intelligence, which is called CoreML. So let's take a look about this. Basically, this is bringing machine learning to everyone. You just have to integrate your model, and CoreML does basically all the job for you. But the problem in this particular sentence is the your model part. Where does this come from? Apple is helping you by providing some object recognition model, 6 of them actually. And do you want to take a look? So basically, you just have to go on the Apple developer website, and they provide you the object recognition model, 6 of them, as I already said, but of several sizes. So it's from 5 megabytes to half a gigabyte. And the main difference between those models is the precision. So it's always 1,000 different objects, and the 5 megabyte one is less precise, and as you may know, the half gigabyte is very, very precise. You download your model, you have a CoreML file, and you just have to drag and drop it into Xcode, and that's what you will have on the ML model. So just to zoom it. It will generate a mobile net, in this particular example, class, automatically generated class. And you will have some information about the inputs. So here, for example, it takes 224 by 224 image, and it outputs you the probability of each object. In code, it looks like that. You just instantiate your model, and you call a method called prediction, here with the image. So you do your application logic to get the image. And it gives you the prediction in real time. Let's take a look. So here is my iPad with a simple app. So as you can see, just giving you the spotlight, the detection object, the object that is detecting. So for example, my phone, which is very accurate, as you may know. You have also. So this is 17 megabytes models directly integrated on the device. And as you may see, it's in airplane mode, so you don't have any network on this, and it's real time. That's Apple, huh? That's not me. But you probably want more, because object recognition model is a great thing, but that's not enough. So you're lucky, because there are a great machine learning community that has already taken part of this particular issue. So this community is organized in several kinds. For example, here you have the neural networks, pipeline, tree ensemble, linear models, etc. But AI stuff, and today we are looking more specifically at neural networks, but you can handle several different problems with those kinds. And Apple is providing you, they are kind enough to provide you a conversion tool, which is in Python. It's common for machine learning stuff. All you have to do is import the library and call the converter related to your model type. So here we have a cafe model, for example, and you just call the save method to your ML model. It does all the conversion for you. So all the community I mentioned earlier are supported, of course, and if you don't get your community yet, and you have a specific work to do, you can even write your own converter. I put it on the documentation here. It's standard pattern. So after the demo I just show you and those community, if we just put it all together, we can do that kind of stuff. Using the vision framework, you can detect several face parts. And on the CAFE model zoo, you can pick a gender classification model, an age classification model, and emotion recognition. And you can get all those information just from the pictures on your device. And you can do it. Right now, this is available for free by the community. Great, right? But you probably still want more. So what I'm proposing to you now is just to create our own model. So basically in computer science, we will start with an hello world. So let's do an hello world of machine learning stuff, which is MINST. MINST is just number recognition. So in this example, we can represent a number by a simple matrix of 28 by 28 values. And what we will do is create a neural network. So a neural network is basically find an activation function in blue, which will detect our number, and a negative function, which will just it's not number, our number. So next example is the actual convolutional neural network, which is creating this stuff. Don't be afraid about that. A neural network is just several mathematical operations applied on the input layer. So here, for example, we have our input layer here, which is our actual image. We just apply a matrix information operation to divide it in 6 several images. We don't sampling the information because there are too much information. We apply another matrix operation on each of these images. After that, you again don't sampling it, too much information. And at the end, once you've done all the parts of just extracting the information on the image, on the actual image, you are doing the fully connected layers, which are basically each dot represents, they called it a neuron. That's why this is a neural network. And each dot is connected to all other dots with just a weight on them. So that's the 2 fully connected layers. And that's the interesting part, because as you may know, once you have your model, we have to train it. So I put all the stuff in this little box, convolutional neural network, and we will apply several iterations of the same data set on this particular neural network. And at the end of each iteration, we have written two mathematical operations, which is the loss and the accuracy. So at the end of each iteration, we are able to compute those things, and with those operations, we will change the fully connected layer to train it and just get a better accuracy and less loss on our data set. That's a very, very quick intro. So an example of our data sets here. So that's just a bunch of numbers returned by hand. There are actually 6,000 samples on our sample. So after this quick intro, I will just demo some code. This code is created by those 2 tutorials, great tutorial by the way. You don't have to understand all the code I will show you. It's in Python. This is just for demo purpose. You can try if you want it on your own laptop. So first, we just init all our stuff. So here I'm using the Keras and TensorFlow libraries. And I'm just getting all the data, the interesting data. Next, we are creating our model. So as you can see here, we have a line for each layer of the model that I previously showed you. And at the end, we are using the loss and the accuracy operation, which are standard machine learning, so they are integrated in our library. Then we do the training. So we just provide our data. We remove, after the training, we remove some nodes which are needed for the training, but not needed for the actual detection. And we save it in the Keras format. And at the end, we're just using the CoreML tools to convert the actual model. So because CoreML is Apple stuff, you have all the basic information of the model, but you have also the extra. So the extra, you have the actual label of the output. You can provide some information about the author, license, description, etc., and information about the input and output that you already seen on Xcode. And you launch it. So you have to trust me about this, because I launched it on this laptop, actually, but it took me 8 minutes for this particular network stuff. So you can do it on your laptop. That's possible. So here we just see the several epochs. We are doing 10 times the same training. And at the end, we get a loss on accuracy. So in the beginning, it was 80% of accuracy. And at the end, it's 98% of accuracy. And we get it, our model. You want to test it? Yeah, okay, great. So let's take a look. I have another sample application, which was returned by the guy which I showed you the link earlier. So here I can draw some numbers, for example, and you can just detect the number with the trained model I've just showed you. So that's it. I'll give you some links to play more. You have the awesome CoreML models collections, which is already trained CoreML models available for you to play. And last one, which is dynamic CoreML, because the ML model is indeed integrated into Xcode. So it's integrated into your binary, but this guy managed to be able to load a CoreML model from the network, so you can basically just train your model server-side and update it on your device over the air. And that's it, just a quote that I love. Thank you.
Thank you very much, David. Thank you. Can you take your mic? Le micro. Merci. Yeah, congrats. It's really an impressive talk, and especially that you didn't stop at the tutorial or just reusing Apple code, but you went all the way down to creating your model and learning your model yourself. That's really impressive. What was your background before? Do you have some machine learning background?
No, actually, I started machine learning back in February, and just because I was curious about it. And I started some stuff using TensorFlow and on the iOS mobile devices.
Can you explain a bit what TensorFlow is?
TensorFlow is just basically the Google stuff, which is a great library to do machine learning on server side and also on mobile side for the other dark side of the mobile and the iOS one.
That is one of my questions. Is like, as usual, we have this technology for our iOS platforms, but do we have a very close counterparts that is very close from what we have with CoreML on the Android side?
Not yet. Actually, TensorFlow Lite is existing. They have just announced it this year. Mm-hmm. But this is not as easy as what I've showed you. Basically, Apple side, you just drag a file and that's it. All is generated for you, and for Google, you have to write code like I showed you earlier.
It's a relatively new technology. I mean, it's brand new, at least at the Apple side. I guess there are already some limitations that you might face. Do you have some that you can explain?
Yes, the first limitation that I just mentioned is the fact that it's actually integrated into your binary file, so you theoretically cannot change the model over the air. If you can change it with this guy method, you cannot actually change the output and output informations, because obviously the Swift code is generated at compile time. That's the first limitation, and the second one is you can only consume your model on the device, and you cannot train it.
Yeah, sure.
Yeah, and could we imagine, because you've done all the machine learning and the learning of the model in Python, which is probably the most used language to do that.
That's the standard.
Yeah, can we imagine doing things like that with Swift? I heard that some guys are trying to implement some machine learning. I mean, creation of the model in Swift. Is that something that?
Yeah, sure. You just have to code it.
Yeah, okay.
No, actually, this is there is nothing really quite ready for doing that stuff in production. Yeah,
and maybe not really important to actually use Swift on the.
Yeah. There are a bunch of stuff online on all those communities, and you can have a great data sets from several data scientists stuff.
Yeah, because usually it's hard to find data, right?
Yeah, that's a big part of it. That's research. So.
Yes, sure. Do you have any specific use case for CoreML, specifically client side? Because I mean, it's quite kind of clear what you can do server side. But do you have some use cases that really need for the model to be run on the mobile?
Yeah, for example, Apple is using it on the Vision framework just to detect several image parts. They are using it with embedded models already inside iOS. And they are using it also since iOS 11 in the NS linguistic tagger to detect the several parts of the language.
Yeah, I recently discovered that all those syntax or natural language processing features that we have in the iPhone for years, at the beginning they were really scripted and not really using learning techniques. It's really strange, but now they switched.
Yeah,
right. That's nice.
You have the same API, but a lot more precision. Yeah.
Yeah. Curiosity from the audience, actually. Do you know of any CoreML-like implementation server side? I mean, as easy as CoreML?
Not yet.
Okay.
You have a great tutorial, but not as easy as that.
All right.
Yeah, that's.
Okay. Thank you very much.
Yeah, thank you very much for learning us about machine learning.